So I'm going to be talking about non-adiabatic coupling of electronic states. So I guess this is the theory. That's probably going to explain it better than I will verbally. So unless anybody has any major complaints about that, I'm probably just going to move on.
You can tell a couple of words.
Okay, so I guess
your interpretation.
Yeah, so for me, when I'm thinking about non-adiabatic coupling, it's easier to think about what it is that you're ignoring when you're taking an adiabatic approximation, which basically just assumes that there's no connectedness between the electronic states and the ionic motion, or the nuclear motion, to be more specific. So whenever you're taking any non-adiabatic couplings, you're actually considering how your nuclear motion is actually moving and messing with your electronic states, and I guess, like you said earlier, ruining the orthogonality and causing different spatial overlaps in time. And I just took that equation straight out of one of the things that you sent in one of those emails. I don't know who wrote it, I guess. There wasn't a name on there.
And where are coordinates from molecular dynamics that Daniel has computed or taught us how to compute?
That would be the big R, I guess, in both
And
cases.
where is your time?
The T.
But
Anything else, but they are not in online.
okay, probably you need to kind of you. Is here one electronic small r and one is a big one, right?
Yeah, that
So,
notation is a little confusing.
In a way, how is it written? You take,
I think what they're assuming is that you have all
you
of
just
your...
overlap two Kansham orbitals at
Yes.
moment t and at moment t plus delta t.
Right.
But this dependence stays only on the nuclear time dependence part.
Yes. So the little r, I would imagine, is just whatever point in the space you're looking at, and then these are, the set of all of
So your
ionic
electronic
or-
degrees of freedom don't change with time? They don't depend on temperature, on temperature, on time?
Oh, I see what you're saying. Yeah.
So I can do that for myself.
Well, okay, they would have a time dependence through this, I would imagine, because you could determine your electronic state based on your ionic positions, right?
Mm-hmm.
So because you have
technically-
the time dependence in there, you
So
would then get your...
technically, you're kind of thinking that your position of nucleus is kind of a snapshot,
Yes.
right?
Yeah.
So it's fixed at that moment of time.
Right.
And it's not really moving because they are very slow.
Yeah.
But you
That's-
still, of course, including that your electronic degrees of freedom is still time dependent, right? And you kind of solving this equation, which you have this delta t in the front and so on, as a dependence for electronic degrees of freedom.
Say that last part one more time for me. Something about the electronic degrees of freedom. I missed a couple words.
In other words, your r, well, your wave function
Yeah.
dependent on a r with the index I, right?
Yep.
And the wave function dependent on a r with the index j, right? They are not orthogonal. Because
Right.
otherwise, if you don't have time dependency for your r, and r is exactly the same, well, I mean,
Yeah,
they have to be orthogonal, right?
Right.
Which means if they have different indexes,
They
then
be
this
zero.
integral should goes to zero.
Yep.
But they are not, because technically you're taking them at different moment of time.
Right, yeah, because we've got...
And that's why
different
this
different
overlap
positions.
will have some values, right? Okay.
Right.
But nuclear are considered like really fixed at this moment of time.
Yes. Or at least as far as I'm aware, yes.
I would say I would put it probably backward, like your nuclear is not time dependent, but your electronic degrees of freedom should be time dependent
Okay.
in this equation. But if you understand it, it's fine.
Yeah.
Just the way how you define it. You kind of
Right.
answered it already.
Yeah. Yeah, that would probably make the notation. Yeah, I'd have to think about how to write that. Okay, so after you have run your molecular dynamics, I guess you don't explicitly have to make a duplicate directory, but I would highly recommend it so that you can't mess anything up in your original molecular dynamics directory. So just make a new directory, copy everything from your MD directory into that one. If you have any files that start with a lowercase p, just get rid of those with remove p star. it shouldn't affect anything because none of the important files start with a lowercase p. And then you're going to need to edit the POSCAR file. Excuse me. The POSCAR file.
Oh, before you go into POSCAR file,
Yep.
right? So it looks like you don't have wavecars on these directories as an output. Am I right?
Oh, it's right there.
But it's only once. But again, you run dynamics. It should be time dependent then. So your wavecar has information on each of your time scale along the trajectory? Or it's just a wavecar which is taken at the very last moment of your trajectory?
I actually don't know exactly what the wavecar has. It's a binary file, so I would imagine that our car has a lot of the vital information.
You can take a
for
look on the
that,
size of the wavecard. I mean,
Yeah.
just I should be curious about it.
Mhm.
So you can take a look on the size of the wavecar when you create it after the first step of the dynamics.
Yeah,
And if
then
the
look at
size
it
is not
later.
increased,
Yeah.
doesn't matter was it binary or not. If the size is exactly the same after you'd run thousand or how many steps,
Right, then you're clearly
so
not
clearly
changing
it's just
size.
rewriting your wavecar at each moment of time. And I think this is what is that. What is it doing?
I think
It's
that's how
not
that
collecting information on a wave function at each moment of time because then your file would be enormously
yeah,
huge in
gargantuan.
size. It's just rewriting your wave card at each moment of time.
Mhm.
But would you recommend to use this wave card, save it? Is it really useful? Because you said like, oh, you have to duplicate everything from your files. What about this file?
You shouldn't explicitly need that. Well, no, you. Okay.
So
Later on, you will need a wavecar file,
so
but that will be
later
generated.
on, actually, we have to recalculate this wave card.
Right. Yeah,
at
and you
some
need
stage.
to recalculate it every
Then
time.
the question is, why do we recalculate and why we're not using it right away? So why to do it twice? Spending time for nothing then. There should be some tricks there then.
Why are we doing what exactly twice?
Why are we not using this wave card? Why we actually have another step to run the WASP and recalculate the wave cards when we calculate nonadiabatic couplings?
Oh, yeah, I see what you're saying. That
Or we
would
use these
actually,
wave cards.
Yeah, that seems like that should be a shortcut.
This is your
should be
after running
viable.
MD, right? So this is
Right,
just
yeah.
you. This is what kind of part which Daniel was discussing,
Mhm.
right? So you run your molecular dynamics. You got all these files.
Yeah.
Right?
Well, yeah.
And
'cause
we
if-
not, and then you're saying you copy everything. You're renaming your POSCAR. I guess this would be on your next slide. But actually, you're renaming your CONCAR probably, right? Not POSCAR.
Conquer to POSCAR.
Yeah. You use CONCAR for the next step, not POSCAR.
So Conquer has a last geometry.
Right. Yeah. It's a
And
postcard. but at the
webcam
end.
also the wave function
Oh.
of the last step.
POSCAR has your initial geometry, but you need
Yes,
CONCARs, which
but-
include all information.
I believe that we actually want the postcard and not the concar for this part.
Let's not
I would
confuse
think-
confuse each other. Tell us first how many slides do you have?
Like 10.
Okay, before going through the slides, give us in one word or two words approximate content of each slide.
So
And this is slide number 3?
yeah,
Number
something like
2.
that.
Number
Yeah,
2.
this is like the very beginning of what you actually do to calculate your couplings. Because this has turned into a multi-step process every time I've tried to do it. So you run molecular dynamics, then you want to create all of your like pXXX files where XXX is whatever number.
So
added with-
okay, good.
And then?
Um,
And you will explain how you do it. But then?
Yeah, so after you have all those, I guess I wrote a script on here that I'm going to mention that if you have your molecular dynamics separated into multiple runs, because you couldn't do it all in 48 hours, which is what happened every time for me, then you need to rename hundreds of these P whatever files. So that script basically, and then I'll make a separate directory where you actually do all the coupling computations and run those
So
scripts.
about the coupling computations.
Yeah.
What is the connection between this pXXX file and coupling computations?
The coupling computations use those pXXX files, which are essentially they're the exact same thing as a postcard, but at whichever ionic step.
Aha.
Here we
And
disagree.
now please tell what is the connection between pXXX files and question that Daniel was curious about.
Which
Oh
question?
crap! Which
Can
question
you
was
rewind
that?
the question?
Yeah.
Daniel was trying to answer which information
Oh.
his molecular dynamics is funneled towards computation of couplings.
Yeah. So after you run molecular dynamics, you do have all of the information on where all of your nuclei are at every step in time. And so each like pXXX file is a snapshot of your system at that step in time. So we are going to explicitly make a separate file for every next step. And that is coming up next, I guess.
So which number of iBrion you used?
What's that?
Which number you used in iBrion keyword for molecular dynamics running?
Is that the one that tells you, or that tells it which things to compute, I guess? I think that one was 2, if I'm not mistaken. If that's the one,
This is
I always have to look at memory's not my strong suit, so I always have to just look at them on the wiki.
But returning back to my first question, so
Okay.
do we need or don't we need this wave-car?
This wavecar we
Anyone
do
can
not need.
We do not need.
we do.
Well,
I-
if you rerun your molecular dynamic part, because this was like you run it like several times with interruptions. So after you done your first, I don't know how many femtosecond, would you use this wavecar to restart your molecular dynamics? Would anyone use this wavecar to restart
No.
molecular dynamics? No? Why not?
I guess.
It will save you a lot of time because
Oh, okay.
anytime when you run DFT, you
Yeah.
start with a guessing wave function.
Oh.
But you don't need to
yeah,
guess
and that
this,
would
right?
just
If
tell
you have this
exactly
one.
where you should
So
be.
if
Okay.
you have interruptions in molecular dynamics, and if you have a wavecar saved and created successfully,
Then you might as well just throw that in the next directory.
use it as an input file to restart it in the next directory and
Okay.
restart it. You save a lot of time with
Yeah.
this. However, you cannot use this wavecar for the non-adiabatic couplings calculations.
Right.
Why?
Because this is only one step of like 1,000.
Oh, you can
So it's not really-
you can run it and resave it, right? Like save it after one femtosecond when it's created, you can call it wavecar 1, then it will be wavecar 2, and 1,000 wavecars. You can probably save them, but we don't do it. Any reason? Anyone knows why you cannot use this wavecar for calculation of the non-adiabatic couplings, or actually for calculation of just regular electronic structure calculations? Anyone knows? No? Have you been ever trying using this?
John Fogel knows.
John?
Do you,
I don't know, does he hear us?
It is very simple and provocative question. Most of you know the answer.
Does
We
it
don't
have to
usually
do
write it,
with like
so-
spin restriction?
We don't usually write it, that's why I've never used it.
Yeah.
Any ideas?
Does it have to do with like spin restriction versus like non-collinear spin or anything like that?
It's dynamics.
So it is not the optimal geometry. Geometry is very distorted, and
Yeah.
it's only one snapshot, so it doesn't give you representative picture of the electronic structure. And
Yeah.
one snapshot is not sufficient to get non-adiabatic coupling because you need a lot of points, a lot of snapshots.
And again,
Right.
read the manual where they talk about adiabatic, just regular molecular adiabatic dynamics.
Yeah.
They have a recommendations there not to use the wave cars for the electronic structure. If like you run your dynamics, then they recommend to restart, like you have your like snapshots or coordinates, restart, recalculate if you need the electronic structure, these specific snapshots.
Okay.
Don't use these wave cars because they are kind of projected to the new, so to speed up the calculations, the wave card which is created at the last moment
Yeah.
is actually having, it's not the real wave car corresponding to the electronic structure of this moment of time.
Okay.
They kind of project it, they kind of guessing it as a next step due to the motion of nuclei. So it's actually not very accurate wave car in other words.
Okay.
And it's done for purpose because this way how they do it, it speed up the adiabatic dynamics,
Yeah.
but it will be not accurate for the electronic structure calculations.
Okay.
That's why if you need to get just wave functions for electronic structure with this specific geometry, right? You have to just do single point calculations with the saved coordinates from
Yeah.
your previous step, right? You can probably restart your calculation again using this wave card if you want to, but you cannot use it directly and claim that this is your.
Okay. So this would be a different wave car than I would get on like the 1,000th iteration.
When you do
of the for
non-adiabatic
loop in that script.
dynamics, when you like, you will go to this non-adiabatic couplings calculations, right? Because there you also restart your VASP calculations starting with these P
Yeah.
files, which has information on the coordinates, right?
Okay. Yeah.
So, and your settings, your POSCAR actually is different comparing to this adiabatic dynamics. It's just regular electronic structure calculation POSCAR with a single loop,
Okay.
right? Without really motion of nuclei.
Yeah, because I definitely do single point calculations later.
Right.
Yeah, I'll ask you, I guess, something when I get to that point
Yeah.
because
But again, the practical point, if you run in adiabatic dynamics, it's a good idea to probably run it for shorter time, because if you run it for thousands and then you break out, you never really create this wavecard. Maybe that's why you're not using. Because if you run it for the whole period of time, and usually you don't have enough wall time to finish it, right? So then, if it's interrupted, then you never really create your wavecard. So probably it makes sense to run it for whatever some reasonable time, like as much you can do for this specific wall time you are running for your regular calculations. Create your wavecard and then restart. Let's say you're doing 200 femtosecond, then you restart from your 200, going from 201 to whatever next 400 something. Restart it with this wavecard. Then it helps you to speed up the molecular dynamics calculations.
okay.
But for non-adiabatic couplings, this wavecard are not very much useful at all.
Okay. Cool. So, okay, so once you've made your duplicate directory and you've copied everything into it, you need to edit the POSCAR because some of the scripts are not written for this version of VASC. So the only thing that you need to do is just get rid of this line, because all this information is already stored here, so it's just kind of redundant anyway, I guess.
Again, return back. You use this POSCAR from your adiabatic dynamics calculations, right?
Yes.
So this is exactly the format which you were using for adiabatic calculation, molecular dynamics calculations.
Yes, this would be this same
Yeah.
POSCAR as up here.
And again, you have to change it because now you're really not running for your kind of go in. We call it step 2. When you're really calculating non-adiabatic couplings, you restart your you restart your VASP, but now you're not doing dynamics anymore. You run regular electronic structure calculations. Means you just optimize self-consistently with this specific nuclear position. You self-consistently optimize the electronic wave function, and that's why you need to modify your POSCAR a little bit because the formats are slightly different.
Okay. Yeah, because
No.
As far as I know,
It is
this
needed
is the
because
this
code for
script is not written for this version of VASC.
converting. Yes.
So this script is expecting this line to not exist. And so if this line is here, you just get a bunch of blank
Then why
output.
is it here?
It is effect of the bus 4 and 5 only. 5 they have one extra line in POSCAR format.
But then why is it running for dynamics?
But this script is written for bus 4. So it is not about
But
calculation, it's
why
about
you
the
have
how-
this line in your POSCAR for the dynamics, and it's not a problem when you run dynamics with this line in a POSCAR?
There is no problems at all.
Yeah, they are-
So,
Yeah, VASP expects that line.
We do use.
Then why you need to
Wait.
delete it?
Let me talk.
For this thing.
We do use latest version of VASP, number 5,
Yes.
which has different format of saving files. But in our repository, we do have a very good script that was written for the version number 4 that no one wants to change and update. And in order to apply the script to results coming out of version 5,
Are we doing
one
the
needs to remove one line.
Actually, I create the POSCAR differently, so I just
So you make your own
in
way.
Thunder we have only bus 5, so we don't have that issue in
Okay.
4 and 5.
Ah,
We have all same format.
okay, whatever.
Yeah. So, okay, so when you try to run this script, if you just get a bunch of blank lines as output, it probably means that you didn't edit your POSCAR, so just go back, do that, and try to rerun the script. If you get all of this going on as output, then that probably means it worked. Probably still a good idea to just look at one and make sure that you do actually have all the information that you need. So after you've done that, so for me, all my molecular dynamics jobs took more than one run. So I had to break these into multiple directories, and the script that I found was not working for me. It would only work in certain cases, I guess. So what you can do is in your second directory, after you've done all the same steps that I just talked about, you're going to get a bunch of, like
This
P00
is
to...
output? What file is it you're showing?
This is a script that I wrote.
Ah, okay.
Yeah.
But the files, the files
These-
are pXXX.
Yeah, these are the pXXX files.
But how you
So-
create your pXXX and so on? Where
with
did you
this
get your
script.
pXXX? Huh?
You run this script, and this will give
Well,
you
well,
the pXXX.
What is your input for this script?
There isn't one.
Huh?
You don't need to give it a
Well, wait. This is wrong. This script doesn't need explicit input in the command line, but it
Right.
reads some
But it
files.
reads the files from
Oh, yeah,
adiabatic
yeah,
So
that's
which
definitely-
files? Which
yeah.
files?
Which are
do you-
the-
I thought you meant like what.
No.
user
Which
input you
files
need.
does the script read?
What do you need to run? Like, let's say if I have an empty directory
Mm-hmm.
and run this script, what does it tell me? And
Probably
arrow.
just complain and say, you
Yeah,
don't have
we'll,
what you need.
we'll stop and
How-
say something
how
like,
you will
can it
complain?
read the file and gives you the name of the file?
I would imagine outcar and maybe another one.
Outcar and POSCAR.
Okay, yeah.
That's why you have to edit the POSCAR.
As an
'cause it
outcar
uses
or
that
Oh,
exdet
right,
card.
yeah, true that.
Because exdet card is easy. Exdet card has all the postcard formula.
See,
Which file you
it is
use?
named outcar to POSCAR.
No, I'm saying if we do that exdet card, is that wrong? I mean,
No, there is a redundant information. It is repeated in both outcar and exdat.car. They have repeated information.
Outcar has
Yeah,
everything.
so-
Xdatcar has only
But since we need
coordinates.
only a coordinate for this one, I mean, then we can just take it from exdet card.
Yeah.
There's a pretty simple in that
Yes.
case, taking from the out card.
So
But
you're going
you
to tell
run-
how you do this procedure in your talk number 7.
Not yet, I didn't-
You're number 7. Okay, we will.
I have
wait.
just a couple of lines Python code and it get everything from the exdet card.
Very
We
nice.
can do that too. That
Okay.
will make more
Cool.
easier.
Okay, it looks like we have 2 alternatives right now. You can get the same, like first of all, you need input files, right? And this
Yeah,
is
yeah, you got
POSCAR
files.
and outcar, or in as alternative, instead of outcar, you can use xdatcar.
Mm-hmm.
Because outcar has everything.
Right.
Energies,
Yeah, only-
even,
Yeah,
even
just
positions,
literally
everything, right?
yeah.
But xdatcar has only positions. So to creating your, like the goal of using this file is to create this p dot
Yeah, the P
files,
whatever.
which will be used for nonadiabatic calculations,
Right.
right? And you either, like you have a script which working with huge big outcar file,
Mm-hmm.
Jabber has own script which is working with xdatcar,
Exdet card.
Yeah. Which has the same information but just only on coordinates, right?
Yeah.
So 2 alternatives, both might work, but the script which you are using probably works only with outcars. If
Yeah, no,
if,
you
Yeah.
should
if
be
you
able to-
if you use
Nothing
this
weird with that
this
one,
script
ran on
for
xdatcar.
kind of and don't have outcar, it also will give you the arrow, right?
So what is inside this P001, P002 files? What is inside these files?
So they generate.
It's answer to question of Daniel, or question that Daniel is interested in.
It's the exact same format as a POSCAR file.
But physical meaning, what exactly is saved in these
The
files?
positions of your nuclei.
Positions at each
Time step.
moment of time.
So your
yeah.
index at in the name of the file is a time step.
Right, yeah. So this is before you've done any ionic steps. This is the first ionic step, second ionic step, and so on.
And why, let's say, why not to have,
Makes sense?
why not to have p dot, like you have xxx? I think in your case probably 4x, right?
No, real file
For
is
this
4. P is 3.
It's 3, okay. So why not, like if it's just 0, 1, 2, 3, 4, and so on, why not having 1, 2, 3, 4, why you need 3 decimal, kind of, why you put in zeros, right? Like at the moment 0, you have all 3 zeros, right?
I'm not putting zeros. The
You
script
don't?
does that.
Well, I understand, you, so you don't do
they're-
it by hand, that's why you actually write the script.
They're padded for whatever reason.
But do you know the reason? Like,
I
why,
don't know
why
the
to
reason.
worry about it? Any ideas? Why we have this special format for naming 000, 001,
For make it easy
002?
to process in the next one because the script
It's
Python
not
all other
easier.
languages started numbering started with 0.
Any ideas? Anyone working with Fortran, writing codes on Fortran?
Yeah, Fortran is started with 0.
Fortran is actually very picky about the text variables. And when you read these files, because the next step is written in a Fortran for the nonadiabatic couplings, and when it's read these files, it's actually is very picky about this how say number of decimal place digits
Yeah.
in a text format.
So it first it reads it as a text file and then converts into numerical format. But
Right,
if
it's
you-
expecting
if you
that
have
padding
different
to be
lengths,
there.
it
Yeah.
will go.
However,
strange.
if instead of like you use probably the same scripts, right, as we use for running nonadiabatic couplings. But if you write your own scripts, let's say not on a Fortran, but on some more advanced and more modern language, then you probably can completely redo this,
Well,
this
right,
name
yeah,
and
'cause
don't
this-
worry about this 000
Yeah.
and so
You
on.
shouldn't explicitly need this for any real reason other than something requires it at some point down the line. I mean, yeah. Anyway,
But it's doing for you so good. Now you know why it's doing it in this specific format.
yeah. So, okay, so if you need to run molecular dynamics in more than one directory, you're going to, I guess I didn't show it here, that, yeah, it would have taken way too much space. In your second run of molecular dynamics, you're going to get P00, P001, P002, all that again. So you're going to need to shift all those, essentially. So what I did is I wrote this script, renamed pXXX, so that all you need to do is just give it the first input that should appear in your new directory, and it will rewrite all of the P whatever files for you. So if that script fails, like it did in this case, usually, so basically what this did is it rewrote P000 to the first index and then it quit. The issue is usually that you have some other file that's not one of the pXXX files in your directory. So just get rid of all those, try to just get new healthy P whatever files, and then rerun the script.
I don't get you. What is mean healthy P? And
What's that?
what do you mean by healthy P?
Just a second.
LDP.
Am I right? Like
I mean, you said
you
two
break
values.
like to run your like you have, let's suppose you have 1,000 P, right? Named from 0 to 1,000.
Yep.
And you saying that of course you cannot and at each moment for each P you have to run VASP. So you have to run VASP 1,000 times when
Yeah.
you calculate, no, but actually twice more because you around 1,000 times. Along the
Yeah, plus
dynamics.
1. Yeah.
Plus one, yes, not twice, just plus one.
Actually,
So
plus 2.
plus two.
Heating, molecular dynamics, and then 1,000 times.
Oh,
No, no,
yeah.
I mean just for this
Okay,
case.
0 to 999.
Yeah.
But you're saying that you cannot, of course, just run it as a single job and do it 1,000 times of VASP calculations, right? So you have to break it into the pieces.
Mhm.
And let's say you put it like from 0 to 50, from 51 to whatever, 100,
Yeah.
101, 150, and so on, right? This is kind of the goal. And then you rename your, like in each, like you're creating these directories for snapshot, how to say, for regions, right? Or time intervals. And then if each this directory, you rename your P files so they will go from 0 to 50. So before you had from 0 to 1,000, now you have how many? 200 directories with 50 guys.
Yeah.
And now your P is going from 0 to 50 in each directory.
Right.
This is what your script is
That,
doing?
well,
Not
so
really.
that's the original problem. What the script does is takes. Okay, so your first MD run has 0 to 50, right? Your second MD run will have 51 to 100. So what the script will do is it will. Okay, sorry. So after running this script, you're gonna have what, like 20 directories that all have P000 through P50. So you need to go 0 to 50, 51 to 100.
Oh, okay. Now I understand. So you
Yeah.
run molecular dynamics in different directories.
Yeah.
So that's why
Yeah,
you
'cause
run
otherwise you
in
don't
each
write out your
directory. You
files.
run your script for creating this P. So now you have numbering of P in each directory is the same. But now you want to really make it from 0 to 1,000 rather than 200 times from 0 to 50.
Yeah, because if you have
Example.
everything in the same directory, you're gonna end
Okay,
up overwriting
good.
everything,
Okay,
and that's
yeah.
just dangerous.
Is it clear or not? Why he needs it?
Actually, I was texting. Sorry.
Does it calculate
So it-
overlaps of wave cars? So if your indices are mismatched, so you would be like overlapping your first step with your 100th step possibly. So
Because
That's why-
initially you don't have any web car, it's guessing the web car, so that web car may be not 100%.
it doesn't know there was a previous run.
Yeah.
So
Right.
you
Yeah.
just-
Yeah, and the script is always
Yes,
just going to give you
it's
0 to however many steps.
So if you overlap 5 step, you can assume that after 5 step is correct.
Yeah,
If it fails again, let me know so I can
Yes.
debug the script.
I have not been able to break it other than doing stuff like this. Or I guess if you have this situation and you removed explicitly this file, it would probably also break because you have this weird jump right there. That's why I recommend just rerunning the outcard to POSCAR because that takes like 5 seconds. So yeah, just let me know if this doesn't work for you, if you ever need to use it. I'd be happy to debug it. Well, not happy, but I wouldn't mind.
Tolerant.
Okay, so after you have all of your pXXX files, you need to make a coupling directory. So what you want to do is copy the in-car, POSCAR, and K-points from your geometry optimization. Edit your in-car so that you only do a single point calculation, otherwise you're never going to finish, and actually that would mess with your data as well. So after you've done that, you're going to need the scripts in this same directory. So these are all in the bin. You're going to need overlap.exe for sure. You're going to need whichever B script is relevant to what you're trying to do. So standard would be for spin restricted, NCL would be for non-collinear. I think there's like one or two other ones in there. And then you're going to need a script that will actually like request your processor hours. So you need to make in-car and a energy pop, or sorry, input overlap and energy pop for the overlap script. Those are just the same as they usually are.
So is it designed for Edison only?
What's that?
Is it designed only for Edison? Because you said requesting processor or something like that.
Oh, there's
They have a script.
there's the same thing except Corey regular coupling, and you can just make one of these on your own if you want to from a different one.
So what does it do actually? I mean,
So okay, so actually, this isn't super clear on here, I guess. This is the Edison regular coupling one. This is the B script file. So what this will do is you tell the computer cluster, you know, what kind of job you're doing, all that, and then instead of just running VASP, you call this script, and this script is what actually runs VASP. So I guess the important things to, oh, one thing that I forgot to mention, actually. I'm not sure exactly why, but this script only works for me on Edison. It does not work on Corey for whatever reason. I don't know why that is.
did you
I guess.
use the pod module? That's why.
Okay, so on these files, the things that you're going to need to edit are all in the boxes, which got really mangled on the paper print-offs, I guess. So just let me know and I can email you a copy of this thing if you wanted to look at it. So in your Edison regular coupling or Corey regular coupling, you're going to request however many nodes. So right here and right here in the orange boxes, I believe, you need to make sure that those line up with however many nodes you're requesting, and I just put those right there for quick and easy reference. So right here, you just need to tell it what the first pXXX file is that you're going to manipulate, or run VASP on, I guess. And then up in here, you just need to make sure that you have the appropriate looping conditions. So if this is 0, just set this to 1. If this is like 57, set this to 58. And then just make sure that it will actually end at the appropriate time, depending on how many pXXX files you have. And I guess in this little line right here, just make sure that this is actually the file that you copied, and you know, you're modifying right here, otherwise this isn't gonna work. So after you've done that, just copy all of the pXXX files into your coupling directory, and then just run sbatch on your Edison regular coupling or Corey regular coupling, whatever it is that, whatever file it is that you have there. Just make sure that you run sbatch on that file. And that's it. Then you have couplings.
That's it?
Yeah.
Last slide. Okay, let's thank Landon. Let's go one slide back. So please point your laser pointer on the near the orange box. Overlap exe. Lower, one line lower. Here. Yes.
Yep.
So tell us more, just your vision, your interpretation, what this code does.
The overlap.exe.
Yes. Yes.
I guess it makes these OS strength files, so it actually does the computation of your couplings.
So what is the input and what is the output for this code? Even if it is not explicitly mentioned, but what it reads from file and what it writes into file.
It takes your electronic states from your wave car.
How many wave cars?
2 at a time. So like 0 and 1, 1 and 2, 2 and 3, the 2 adjacent time steps. At least I would think. And then it basically calculates this using.
So this overlap dot exe implements this equation
Yes.
for a given time step.
Right.
And your phi at time t is wave car, and
Yes.
your phi at t plus delta t is wave car new, or whatever.
Or, yeah.
Wave car and wave car old.
Yeah.
Okay. And which file can go to the equation?
Oh, yeah.
So this v sub I j,
Yep.
where in which file this v is saved?
That would be. Let's see. Should be
The
in
next
the
line of
OS
code
strength
And if you think longer,
or master equation.
if you think even longer,
Coupling.
yes. So it should be matrix like with orbital indices skipped, like square matrix
Yep.
from first to last orbital, or from first active to last active orbital. Okay.
Yep.
And then in your script there should be renaming of the coupling into
Yeah.
coupling with time index, right?
Right.
MV
Yeah. So
coupling,
it moves
coupling.
it to whatever your
Period.
added new decimal is.
Okay.
I was wondering why is moving coupling to coupling.
No, there is a red,
Yeah, it's
red
these
font which is
colors
not.
don't show up
Oh,
super well
okay.
in here.
Yeah, that's right.
Is it better?
Yes, it is.
Oh, yeah, you also don't need to have this one with the initial zeros, because the printf statement handles that for you. So, yeah.
More questions to Landon? Daniel? You are the target audience for this talk. It's your chance to ask.
I understood most of it, but the part,
Next week you repeat everything.
yeah, the only thing that got a little overwhelming was whenever you had all those P1000 files.
Yeah.
How many files did you have right there? Yeah.
Oh,
files
yeah,
right there.
when it's all said and done, you should have, well, for me anyway, I'm doing 1,000 steps, so yeah, you got like 0 to 999. So it's just a lot. And then this script actually makes a file for every intermittent step, I guess, for an OS strength, for master equation, for coupling. So after you run it, this directory gets massive. Because you have like 4 files for every one of these steps now.
Jabet, you wanted to ask something?
What is the webcar world you just mentioned? Where did you get from?
The wave car?
Webcar world.
Oh.
I saw it now. Webcar and webcar world.
So, okay, so you basically just run VASP on the first pXXX file that you have, and then when you go through in the loop, you just add 1 to that. You move that old wavecar to wavecar old, and then you're going to rerun VASP, except at the next ionic step, I guess, using the next POSCAR. So then after you do that, you're going to have wavecar again, and then when you repeat this loop, you're going to end up replacing that with wavecar old. So you keep rerunning VASP over and over and over again, so you get new wavecards every time.
Okay, if I ask what is the necessity of doing the webcar world from the previous step?
The first one here?
I mean, why are you using one webcar from the previous step?
Oh, because that has
No, previous means the previous time step in the loop.
yeah. So the wavecar old would have this information in it, and then wavecar has this information.
More questions? If not, let's thank Landon once again.
Oh, just a quick one. How do you know how many I's and J's you have for your couplings?
You specify that.
In which file?
Input overlap,
Okay.
and your energy pop, I guess, too.
Yeah.
But yeah, these are, they range from there to there.
Yeah. Thanks for pointing on this. Okay. Thanks, Landon, for one more time. Now